Hello everyone, it's week 7 in Business 2220, and this week we're going to do a problem found on page, I lost the page, it's problem 6.33, which is on page 264, yes, 6.33. What we're doing is filling jars with jelly, and we're selling these jars claiming that there's 16 ounces of jelly inside. Now, people like the Federal Trade Commission, FTC, and other regulatory agencies would like to make sure that we're not cheating the customer. And they say that if we claim 16 ounces, then the minimum we should be filling the jar to is 15.95. Now, on the other hand, we don't want, as the manufacturer of these, producer of these jars of jelly, we don't want to put too much in because that would cost more money. So we want to make sure that there's no more than 16.05 ounces of jelly in each jar. Now the question is, are we meeting that set of goals? And to find that answer, we took a sample of 100 jars of jelly, and that's one jar every half hour, so that's roughly 50 hours, or maybe about 2 days of production. And in that sample, we found that there was an average of 16.0024 ounces. Now that, some people might say, is pretty good. We're well within our range. We're almost exactly on our target. What's to argue about that? Well, of course, the problem is that maybe we had lots of outliers that were greater than the upper limit of 16.05 and lots that were below 15.95. And it just happened they balanced each other out, and the average came out to be in range. What we really need to look at is the standard deviation, which in this case was 0.02454. Now let's take a look at this graphically so we know what we're doing. And to do that, I'd like to introduce a tool that I've produced and have posted in the content area of Desire to Learn, which I call John's Normal Distribution Graph Maker. And what you can do with this tool is to produce a curve, a bell-shaped curve, a normal distribution curve to whatever parameters you desire. It's a little bit kludgy. You have to make one manual adjustment, which I'll show you in a minute. But if you ever want to do this, the tool is available for you. I don't think I ever require you to do it as part of an assignment. Just so you know it's there, you can use it if you want to. What you do is in cell B1 and B2, you enter the mean and standard deviation. Now, the way I have it set up on the website is with a mean of 0 and a standard deviation of 1, which of course is the standard normal distribution. But in this case, we want to have a mean of 16 0024 and a standard deviation of 0.02454. Now when I do that, you notice that my curve disappears, and that's because I have to manually adjust the x-axis labels. Now I've right-clicked on the axis area, and you can see I got a nice little box around it, and this menu came up. And I'm going to click on Format Axis. And that brings up this screen, and what I do is I put in the maximum value of 16, which I've calculated on the spreadsheet right up here. I put in 16.076 and a minimum value of 15.929, close enough. And when I do that and close the window, you can see that now I have the exact same curve, but now the center is at our sample mean of 16.024. I'm going to simply copy this. I'm not in Excel 2003 you do edit copy, or this little symbol that puts a copy of this chart on the clipboard. If I go back to our worksheet here, I'll paste it right here. Now I'm not going to paste it exactly. I'm going to do a paste as picture because I want to paste as picture. I could have just pasted it in the normal fashion, but that would give me links back to the original worksheet. And while that can be helpful sometimes, because if I went back and changed the other worksheet, this one would update automatically. Sometimes those links get broken, they get lost, and it makes it much more difficult to navigate with it. So I just pasted a copy of it. It's now what it is. It's a picture. It's a bitmap of the graph. But that's what we need for this problem. Now I'm going to put some lines in here so we can see where the limits are. I'm going to do insert shapes, and I'll put in a line like this one. Now the lower limit is at 15.95. I'm going to hold down the shift key and draw a nice little line there. You can do this in any version of Excel, of course. I'm going to make it red. So we'll go over here and say, let's make it red. And let's make it a little heavier. So let's call the weight 3 so we can see it better. And I'll put another one in. Insert a line over here. Hold down the shift key. It's 16.05, our upper limit. And I will again make it red and make it 3. Now, getting these lines straight is devilishly hard, but don't worry about it in the homework assignments. Just put them in roughly the right spot. If they're not perfectly straight, I'll get the idea. I don't want you to spend a lot of time trying to make them look pretty. Notice that the left-hand limit is at a lower point in the curve than the right-hand limit. I wonder why that is. Well, the reason is that I drew the curve with 16.04 as the mean, but these limits were set with an assumed mean of 16. So that little difference is throwing off the upper and the lower limit. But that's okay. We'll accommodate that. What this problem is asking us graphically is to calculate the probability that a randomly selected jar will fall outside of the specification. If it's in the specification, it'll be somewhere in this range, but it could be that the sampled value, the sampled jar, will be less than 16.05 or greater than 16.05. And the area under the curve above and the area under the curve below is the probability that we fall outside that range. And that's what we really want to calculate. What's the probability that we select a jar? It'll be less than this. Probability if we select a jar, it will be greater than that, 16.05. So to do that, what we're going to do is use the normal distribution table. I've reproduced a portion of it here in the spreadsheet. You can see I put the z-values down the left and across the top, just as is done in figure 6.1, which you can find on page, I'll flip to it here. Is it 6 point? Where'd it go? I lost it. Here it is, 651, 251 and 252. You can see how I did it. I put in here they used the function equal normdist, N-O-R-M-D-I-S-T, normal distribution. And if you put in a z-value in norm distribution, norm S distribution, I should say, and you see the S in there, that means standard distribution. So if I put in a z-value, I will get the associated probability. Now this probability, if you look on page 251, is the area to the left of the z-value. So that is going back to our picture, that would be this area over here. When I use the upper limit z-value, I'll get this area over here, and we'll have to accommodate that, which I'll show you in a minute. Okay, so what we have to do then is calculate some z-values. Now, let's do that right here. I'll put a label that says z. Now, the lower limit of z will be equal to the difference between the minimum value, 15.95, and the sample mean of 16.04. Now, that will give us the difference measured in ounces, but we want to know how many standard deviations it is from the mean. The lower limit is from the mean. So we'll divide it by our sample standard deviation. And we get a really big number. Make it a little bit bigger. Woo, that's too big. Let's bring her back here. We get 2.153. A negative 2.153 is the 1353 is the lower limit. The upper limit is equal to the same thing, the maximum value minus the sample sample mean divided by the sample standard deviation. We get a plus 1.939. Okay, I got to quit and start a B version of this video, so stay tuned. I'll be right back.